Ever heard of ball lightning?
Oh, yeah, definitely. One of those things, well, it really makes you wonder where science ends and folklore begins.
It's like a ghost story, right? A glowing ball of light just floating around, even passing through walls sometimes.
Sounds impossible, right? But people have been seeing these things for centuries, often during thunderstorms. There are accounts from ancient Rome, sailors during the Age of Exploration, even people today.
That's wild. And after all this time, all these sightings and research, ball lightning is still a total mystery. We have tons of historical accounts, meteorological observations, physics experiments, but no definitive answer.
Yeah, it's like a puzzle with pieces scattered all over the place across time and different areas of science. You've got historians going through old accounts, meteorologists looking at weather patterns, physicists trying to make it happen in the lab.
So everyone's working on their little piece, but nobody's got the whole picture.
Right, and that's what's so cool about this deep dive. We're going to try to put those pieces together, see if we can understand this crazy phenomenon a little better.
All right, well, let's start with the historical record. We've got reports of ball lightning going back centuries, even millennia. What were people saying back then? Was it just dismissed as superstition?
Well, actually, no. Even respected figures like Seneca, that Roman philosopher, wrote about these glowing balls that seemed to come down during thunderstorms. He called them balls of fire.
So even back then, they knew there was something weird and powerful about these things.
Exactly. And it wasn't just ancient Rome. Sailors during the Age of Exploration often reported ball lightning around their ships' masts, which just added to the mystery.
Oh man, I can just picture those sailors already superstitious about the ocean, seeing these balls of light around their ships. Terrifying.
Totally. But it wasn't all fear. There was a sense of awe, too. Some cultures even thought ball lightning was a message from the gods.
So for centuries, ball lightning was kind of wrapped up in mythology and superstition. When did science actually start taking it seriously?
That shift really started in the 18th and 19th centuries with the rise of modern science. Scientists started to keep track of these events, organize them, try to find patterns and explanations.
But they didn't have the right tools or knowledge to really figure out the physics of it all, right?
No, not yet. But they were doing the groundwork, collecting data, asking good questions, and that led to some of the first scientific theories about ball lightning.
Okay, so let's jump to the modern era. What are scientists saying now? Do we actually know how ball lightning forms and acts?
We've definitely moved past just guessing. Modern meteorologists, for example, have connected ball lightning to thunderstorms, suggesting it has something to do with all the crazy electrical activity and the specific weather conditions you find in those storms.
Makes sense, since it's often seen during thunderstorms. There have to be some link.
Right, but exactly how they're linked is still up for debate. One interesting theory looks at what happens when lightning strikes the ground.
Okay, what's so special about a lightning strike hitting the ground?
Well, when lightning strikes, it gets super hot, hot enough to vaporize stuff, especially silica, which is found in soil.
Wait, you mean the ground itself can turn into vapor?
Exactly. And when that happens, it creates this bubble of ionized gas trapped by the heat and pressure from the strike.
So we've got this pocket of superheated electrified gas. Is that what ball lightning is? Just a glowing bubble of dirt?
It's not quite that simple. That supercharged air, as you call it, is what we call plasma.
Yeah.
It's matter where the atoms have lost some electrons, so you've got all these charged particles floating around, and that's where things get really interesting.
Plasma. Huh. I remember that from school, but it always seemed kind of abstract. What's so special about plasma when it comes to ball lightning?
Well, for one thing, plasma conducts electricity, which means it reacts to electromagnetic fields in some really cool ways. And that might help us understand some of the crazy things ball lightning does.
Okay, now you've got me interested. Tell me more about how plasma and electromagnetism could be connected to ball lightning.
All right, picture this. You have this ball of plasma made by a lightning strike. Plasma can actually make its own magnetic field.
So the ball lightning is creating its own magnetic field. That's insane.
It is. And that magnetic field might explain how ball lightning keeps its shape. Think of it like a tiny, glowing version of the sun, held together by its own magnetic forces.
Like a magnetic bottle.
Yeah.
Like it's containing itself.
Exactly. And that same magnetic field could explain how it moves as it interacts with other electromagnetic fields around it, like power lines or even the Earth's magnetic field.
Okay, so that starts to make sense. But there's still this huge question I have. If ball lightning is this superheated plasma, where is it getting the energy to stay lit? It's not like it's plugged into a wall.
That's the million-dollar question, and there are a lot of ideas out there. Some people say it's trapped microwaves, also made by the lightning strike.
Microwaves, like the ones in my kitchen.
Sort of, but way more powerful. These microwaves could be stuck inside the plasma, constantly giving it energy.
That's wild. So we have microwaves as a possible energy source. Any other theories about how ball lightning keeps going?
Oh, there are plenty. Another theory says that there are chemical reactions happening inside the plasma using reactive gases from the atmosphere, like ozone.
So it's like a mini chemical reactor making energy from the air around it.
You could think of it that way. And there's another really interesting idea that involves silicon. Remember that element we talked about that gets vaporized by the lightning strike?
Yeah, I'm listening. What's this silicon connection?
Well, some scientists think that when lightning hits soil that's full of silicon dioxide, it doesn't just create plasma, it creates a special kind of plasma that's powered by silicon.
So you mean the ball lightning is actually burning silicon as fuel?
That's the idea. And get this, there have been cases where ball lightning disappears and leaves behind silicate residue. It's like ashes from a silicon fire.
Whoa, that's some convincing evidence. But if it's burning silicon, shouldn't there be smoke? Where does that fit in?
It does seem weird, right? But they think the silicon combustion in ball lightning is a very specific kind of reaction that doesn't make visible smoke. More like a slow, smoldering burn than an open flame.
Okay, that makes sense. So we've got this potential energy source from silicon, but even if we buy that, there's still this other huge GE mystery. How can something made of matter pass through a wall? That breaks the laws of physics.
It seems that way, doesn't it? But remember, this is plasma, not your average solid, liquid, or gas. And those electromagnetic fields we talked about might be the key.
Remind me how those fields could explain the whole wall passing thing.
The magnetic field around the ball lightning isn't just sitting there, it's always changing. And it can interact with the electromagnetic fields of other materials, like the atoms in a wall.
So you're saying the ball lightning's magnetic field can somehow affect the atoms in the wall and make a way through?
Some scientists think that's possible. They've even compared it to something in quantum mechanics called quantum tunneling.
Quantum tunneling sounds like something out of Star Trek. What is that exactly?
It's a crazy concept.
Yeah.
Basically, in the quantum world, particles can sometimes pass through barriers that they shouldn't be able to, according to our normal understanding of physics.
So it's not really passing through the wall, more like teleporting to the other side.
Not exactly teleportation, but yeah, it's a wild idea, and it's still very theoretical.
Okay, so quantum tunneling is one possibility. Are there any other ideas about how ball lightning might interact with solid objects?
Yes, there's another thought that focuses on surface conductivity. Maybe the ball lightning doesn't actually go through the wall, but travels along its surface.
Like it's clinging to the wall, using it as a guide.
Exactly. And this theory is interesting because ball lightning is often seen near things that conduct electricity, like metal pipes or wiring.
Yeah, that makes sense. If it's drawn to those things, it would make sense for it to follow the easiest path along the surface of a wall.
Exactly. And this idea also helps explain why ball lightning is sometimes seen coming into buildings through chimneys or other openings. It's not defying gravity, it's just sticking to a conductive path.
Okay, so we've got quantum tunneling and surface conductivity as possible explanations for how it goes through walls. But both of those ideas still seem pretty out there. Are there any theories that are a bit more grounded?
Well, there are some theories that say ball lightning isn't actually a real object, but an optical illusion.
An optical illusion, you mean it's not really there?
It's a controversial idea, but some scientists think that ball lightning might be an afterimage caused by the intense light of a lightning strike.
Like when you look at a bright light and close your eyes and you still see the image.
Kind of, but way more complicated. The idea is that the bright flash from lightning can overload your vision for a bit, creating a lingering image that looks like a glowing sphere.
That's interesting, but if it's just an illusion, how do you explain the stories of ball lightning moving, making noise, even interacting with things?
Those are the tough parts that this theory has to explain. Some people argue that these things could be psychological, like people being suggestible or misinterpreting what they're seeing and hearing, but it's a tough sell, even for scientists who are open to new ideas.
I get that. It's hard to just dismiss all those eyewitness accounts as people imagining things. But hey, that's science, right? We have to consider everything, even the impossible stuff.
Totally. And even if the illusion theory is wrong, it makes us question what we think we know and look at the evidence carefully.
I like that. It's good to remember that we shouldn't take anything for granted, especially with something as strange as ball lightning.
Speaking of strange, we've talked a lot about what ball lightning is, but not much about how it moves. People often say it's unpredictable, like it has a mind of its own.
Yeah, it's like it's dancing to some invisible beat. What do scientists say about that?
That's where it gets even more complicated. The way ball lightning moves seems to depend on a few things: electromagnetism, air currents, even the shape of its surroundings.
So it's like a tiny boat caught in a bunch of currents and winds, but also being pushed and pulled by magnetic forces.
That's a great way to put it. And just like a boat, ball lightning can be moved in different directions by all those forces, which makes it look like it's moving randomly.
Like it's feeling its environment and reacting in real time.
It does seem kind of alive, right?
Yeah,
But we're not talking about actual consciousness here. It's just physics and the way different forces interact.
right. But it's hard not to be amazed by how complex and beautiful this whole thing is.
I agree. Ball lightning shows us how full of surprises nature is and that we still have so much to learn. But let's come back down to Earth for a second. We've covered a lot of theories, but we're still pretty far from a definite answer. Do you think we'll ever fully understand ball lightning?
That's a tough one. But what I find exciting is that even if we never completely solve the puzzle, the process of trying to figure it out is just as cool. The search for knowledge, pushing the boundaries of what we understand, that's what makes this whole thing so interesting.
You said it. It's not always about finding the answers, but about asking the right questions and being open to the unexpected.
I'm with you on that. But I'm curious, with all the research that's been done, are there any practical uses for this knowledge? Can we learn something from ball lightning that could actually benefit humanity?
That's the so what question, and it's a good one. Because even though seeking knowledge for its own sake is important, it's natural to wonder if there are any real-world benefits to studying something as mysterious as ball lightning. And it turns out there might be.
Okay, now I'm hooked. Tell me more about these potential applications.
Well, one promising area is plasma physics. Remember how we talked about ball lightning being a self-contained ball of plasma? If we could figure out how to make and control plasma like that, it could revolutionize a lot of things.
Like what kinds of things?
Well, one obvious one is fusion energy. Fusion power, which is like recreating the sun here on Earth, relies on making and controlling extremely hot plasma. If we could understand how ball lightning stays stable, it could lead to big advancements in fusion reactor design.
Wow, that would be amazing. Solving the world's energy problems thanks to ball lightning. Who would have thought?
It's an exciting possibility. But fusion energy is just one idea. Understanding plasma better could also help us make progress in areas like lighting, materials processing, even medical treatments.
So by studying this weird, elusive phenomenon, we could end up with cleaner energy, better manufacturing, and new ways to fight disease.
It's definitely possible. Ball lightning shows how research that's driven by pure curiosity can lead to amazing discoveries that have a huge impact. But let's not get ahead of ourselves. We still have a lot to learn about ball lightning, and there are lots of challenges to overcome before we can turn this knowledge into something practical.
Good point. We need to be realistic about our excitement. But even if those potential applications are a long way off, the process of learning about it is still really valuable. And who knows, maybe one day we'll look back and realize that ball lightning, this crazy thing that has fascinated people for centuries, helped shape the future.
I wouldn't rule it out. The universe is full of surprises, and ball lightning is a perfect example of that. But we're running out of time for our deep dive today, and there's one more fascinating thing about ball lightning we haven't talked about yet.
Okay, I'm all ears. What else have you got?
Well, we've talked about how it forms, how it gets its energy, how it moves, even its possible uses. But there's one question that often gets overlooked. What happens when ball lightning disappears?
That's an interesting question. It just vanishes.
Not always. Sometimes ball lightning leaves behind physical evidence, and that evidence might help us unlock some of its remaining secrets.
Okay, now you've really got me curious. What kind of evidence are we talking about? And what could it tell us about this mysterious phenomenon?
Well, that's a story for another time, but let me just say this. The final chapter, the ball lightning story, is just as amazing as the rest.
You know me too well. You've
That-
definitely left me wanting more.
Haha. So let's get back to that silicon idea. It's a pretty cool theory.
It really is. This idea that ball lightning might be powered by burning silicon, it almost sounds like science fiction.
It does have a certain, I guess you could say, elegance to it. But what's really interesting is that there's actually some evidence to support it. When lightning strikes soil that's rich in silicon dioxide, it can create a luminous plasma. And get this process might actually release enough energy to keep ball lightning going for a while.
So it's not just the energy from the initial lightning strike. It's like there's a tiny furnace inside,
Yeah.
burning silicon particles as fuel.
That's the idea. And remember those cases where ball lightning leaves behind some residue? Well, that residue often contains silicates, which would be what's left over after silicon burns.
That's pretty wild. It's like finding ashes from a fire that shouldn't even exist.
Oh, wait. If the silicon is burning, shouldn't there be smoke? How does that work? That's a really good question. It does seem counterintuitive, but the way silicon is thought to burn in ball lightning is very specific. It's a type of reaction that doesn't produce visible smoke. Think of it more like a slow, smoldering burn instead of a big flame.
Okay, I can see that. So we've got this possible energy source from burning silicon. But even if we believe that, we still have this other massive question. How can something made of matter go through a solid wall? It just doesn't seem possible.
It definitely challenges how we usually think about the world, right? But remember, we're dealing with plasma here, which acts very differently from ordinary matter, and those electromagnetic fields we talked about earlier could be the answer.
Okay, I'm with you. The plasma makes its own magnetic field. But how does that let it interact with a solid wall?
Think about it like this. The magnetic field around the ball lightning isn't static, it's always changing. And it can interact with the electromagnetic fields of other materials, like the atoms that make up a wall.
So you're saying the ball lightning's magnetic field can somehow influence the atoms in the wall and make a path for itself?
It's possible. Some physicists think this interaction could, under the right conditions, weaken the bonds between atoms in the wall, creating a sort of tunnel that the plasma can move through.
Hold on, are we talking about quantum tunneling again? Because that's a pretty big leap.
I know what you mean. It's a mind-blowing idea.
Yeah.
But quantum tunneling has been observed in other situations, so it's not completely impossible. Basically, it's when particles can go through barriers that they shouldn't be able to, according to our usual understanding of physics.
So you're saying the ball lightning might be using some weird quantum trick to get past the wall.
It's an interesting theory, isn't it? But let's not get too focused on quantum mechanics just yet. There are other simpler theories about how ball lightning might interact with solid objects.
Okay, I'm open to hearing other ideas. What else is there?
One alternative explanation focuses on surface conductivity. The idea here is that ball lightning might not actually pass through the wall, but instead travels along its surface.
So it's kind of like it's clinging to the wall, using it as a guide.
That's it. And this theory is especially interesting because ball lightning is often seen near things that conduct electricity well, like metal pipes or wires.
That makes sense. If it's attracted to those materials, it would naturally follow the path of least resistance along the wall surface.
Exactly. And this also helps explain why ball lightning is sometimes seen entering buildings through chimneys or other openings. It's not defying gravity, it's simply sticking to a conductive path.
Okay, so we have quantum tunneling and surface conductivity as possible ways it gets through walls. But to be honest, both of those still sound pretty crazy to me.
Yeah.
Are there any theories that are a little more down to earth?
Well, there are some theories that say ball lightning isn't actually a real physical thing at all, but rather an optical illusion.
An optical illusion. Wait, you're saying it's not really there?
It's a controversial idea for sure, but some scientists think ball lightning might just be an afterimage created by the super bright light of a lightning strike.
So like when you stare at a bright light and close your eyes, you still see the image for a few seconds.
Similar, but on a much more complex level. The idea is that the lightning flash is so bright, it can overwhelm your visual system for a moment, and that creates a lingering image that looks like a glowing sphere.
Interesting. But if it's just an illusion, how do you explain all the reports of ball lightning moving around, making noise, even interacting with objects?
Those are the challenges this theory has to address. The people who support this theory say that some of these effects could be psychological, like people imagining things because they're expecting to see something unusual or misinterpreting what they're seeing and hearing. But it's a tough argument to make, even for open-minded scientists.
I can see why. It's hard to dismiss all those first-hand accounts as people just seeing things. But that's science, right? We have to keep an open mind and consider all the possibilities, even the ones that seem impossible.
Absolutely. And even if the illusion theory turns out to be wrong, it makes us think critically about what we think we know and forces us to really examine the evidence.
I like that. It reminds us not to take anything for granted, especially when dealing with something as mysterious as ball lightning.
Speaking of mysterious, we've talked a lot about what ball lightning is, but not so much about how it moves. People often describe it as unpredictable, moving around almost like it's alive.
Yeah, that always gets me. It's like it's dancing to some rhythm we can't hear. What do scientists say about that?
Well, that's where things get even more complicated. The way ball lightning moves seems to be affected by a bunch of different things, including electromagnetism, air currents, and even the shape of the environment it's in.
So it's like a tiny boat caught in a complex system of currents and winds, but with the added factor of electromagnetic forces.
That's a great way to think about it.
Hmm.
And just like a boat, ball lightning can be pushed and pulled in different directions by all those forces, which explains why its movements seem so random and unpredictable.
It's like it can sense its surroundings and react to them in real time.
It does give you that impression, doesn't it? But of course, we're not talking about consciousness or anything like that. It's all about the laws of physics and how different forces interact.
Right, of course.
Yeah,
But it's still amazing to think about the complexity and the beauty of it all.
I completely agree. Ball lightning reminds us that nature is full of surprises and that there are so many mysteries still waiting to be solved.